Hello everybody and welcome back to another FPS game tutorial, and in this tutorial I will make something which wasn't in the original planning, but I feel that it is an important subject, and this is the networking. A few days ago actually I overcome my laziness and implemented this simple server client networking multiplayer feature for our FPS game. So now multiple players can join to the game and shoot each other. Of course it's not too interesting, and collisions here a little big, so it's quite easy to hit someone. Maybe I will change that later on. But for now I will just implement the server client model, so we will see how the communication actually happens whenever there are multiplayer feature. Okay, so I made a little drawing in game, and I will show you the basic communication, how the server and the clients will communicate. The server is actually a standalone program. It's not part of the FPS game, but actually it's a completely new program. It can be run on a remote machine, so a completely different machine, or it can run on the same machine as one of the FPS game instance, or basically any kind of combination. The client, actually in my case, wherever I will test, all the clients will run on this machine. Maybe I will try to connect via the LAN, so the internal network, local area network, with my laptop later on. But for now we will just implement the server, and later on we will care about trying it out. So, I didn't mention in the last tutorial about SDLNet that although you can pass anything to SDLNet TCP send and SDLNet TCP receive as the void pointer, so you can pass any kind of data type, or you can just get a pointer to a player instance and send that over the network. But that's actually not a good idea, and that's because there are no rules how the data representation in one, how the data is represented. For example, the floating point number somewhere represented as 4-byte number, a float, somewhere as 8-byte. So it could be difficult, and there are the byte ordering or endianness too, and this kind of cause problems whenever we want to make a networking program which run on any platform, on any computer. So instead I will do that I will send string literals, because the character cannot, because the character is 1 byte in every computer. A char is 1 single byte, and of course the byte ordering doesn't really matter since it's just 1 byte, right? So I will use basically string literals to send numbers, floating point numbers, and I use the scanf and the sprintf, which we have already used in the past, which makes a number or any kind of data into a format which we want. Okay, so let's see how the communication will happen. So first of all, a client, whenever we want to connect, will send a message with just a simple 0. And in the server we just read this and create a socket for this client, so later on we will know how to communicate with this client. And then we push it back to a vector, so we will have a vector of players in a server. For example, if there are 30 players in the server, there are 30 elements in that vector, right? So this is quite simple, and we use a unique identifier to identify every single player on the server, and actually the clients identify each other with this ID as well. So if this client would want to send something to this client, then use the ID of this client basically. So the ID is very important whenever we communicate in the network. Every single client has a unique identifier. Okay, so the next thing is that every single frame, every client will send a message to the server, which will basically the position, rotation, looking direction, the current weapon number, so on. So a bunch of possible variables in here, and this will send it every frame to the server, and the server will basically send this to every single other client basically, and that will code, and so the other clients will know where this player is, so they can put a mesh there. And the current frame, of course, we will use that as well. So we'll send the current frame, so other clients see that this client is walking or shooting and so on. Okay, so the next thing on the list is actually the disconnect, I believe. So with the number, with the starting number 3, by the way, I didn't mention this. The first number always identifies what kind of communication is it. So 0 is connect, 1 is the usual every frame data, and 2 is the server is full or something. So every single number in here has a meaning. So according to the first number we will process the data after that. Okay, so we send the ID, and that's basically removed from the vector, and so basically delete just this client, so that client no longer playing. And of course send every single other client that this client is disconnected from the server, so everyone could remove from their local vector this client, because every single client will hold a vector for all the other clients basically. Okay, so the next thing is actually if one player shoot another one, this is a separate message, and it will start with the number 4, meaning that one player shoot another, and it will send the own ID, so the client's ID. It will send the ID who this player shot, for example this client right here, and it will send a number, so how much health should be decreased from this player. And then the server will send this message to the client, basically who was shot, and the local calculation of the health happened there. Okay, so the next thing is actually that's pretty much all the messages which we will send via the server, and of course this can be extended in the logical way. So of course if you want another kind of message, I don't know, that the player hit a wall or something, then you just get a unique identifier for that message and send the data, expand the server, so on. And the other thing is the client's perspective. The client will send a lot of kind of messages and receive a lot of kind of messages, basically all the messages it sends which I shown you, and waiting for the incoming messages. I'm not sure this part of the idea is very clear, so I will just skip this for now. Okay, I have already set up a little code for the server. This will be the server, and this is just a basic setup of the SDLnet, except this line right here, this define SDL reinterpret test. This is a macro which is needed for the SDLnet to work, and probably that's just needed for me because I have the newest version of the SDLnet, but I have an older version of the SDL itself, because I have a very outdated operating system right now set up here, and actually none of the software sources work anymore for Ubuntu 9.10. So this macro is basically just missing from my implementation of the SDL, but we can easily define it right here. Probably you don't need it if you have the newest version of both SDLnet and SDL. Right, so the server will basically get the messages and do the connection, disconnection, and basically forward the messages to the player who is needed. That's basically all the task for this main. And actually for that, every single player has an entry called data, so I will make it right here, data. And this data will contain data for every single player. It could contain things like the number of the health, it could contain the points, the number of deaths, so on. But to make it simple, this will only contain the socket, so TCP socket, and I just call it socket. It will contain a variable called uint32 timeout. This with an e. Okay, with this timeout variable basically does that whenever we don't get a package from a player for a longer period of time, for example 5 seconds, then we automatically assume that that player disconnected. Just somehow the message which was the disconnection doesn't get to us in time, doesn't get to us because, I don't know, the network just disconnected for him, or rage quitted, or there could be several kind of situations. So if we don't get a package from a player for a long period of time, for example 5 seconds, then we automatically disconnect it to free the resources, and it will not show that player still there whenever it's already quitted for all the clients. Okay, and we store the ID of every single player, and of course this ID will be a unique ID. This is the same ID as we send it to the player. Right, okay, and we need to make a simple constructor for that. This is a very simple constructor, socket, and uint32 timeout and int ID, and just assign this the socket is sock to socket, and then the time out equal to t, and then the ID is equal to I as the ID. Right, so this is a very simple structure which holds the most important data for every single player. We will create a vector for that for every connected player. Okay, and let's go back to the main. This is not an object-oriented program. This is just a basic loop, so it's like the earlier SDL program pretty much. Okay, so first things first is to initialize the SDL and SDLnet. So SDL underscore init, and just initialize everything, SDL init everything, and is initialize the SDLnet as well, so SDLnet underscore init. Right, and immediately deinitialize it before I forget, so SDL quit, and before I do that actually SDL net underscore quit. Okay, now all the allocated resources has been freed, so let's go back to the variable. We need quite a few variables actually. We need a cure ID, it's an integer, and actually it starts from 0. This will be the unique identifier for every single player. So the first player will get the identifier 0, then the second player get the identifier 1, and so on, so this will always increase. Then I have another variable which contains the player num. This is actually the player number, so how many players are there, and again it starts from 0 because no one is connected to the server yet, and this will increase every player which connected. Although this two variable is the same, but actually whenever disconnect someone from the server, the player num will be decreased, but the ID will be not, so that's the difference. But at first they are pretty much the same until no one disconnects. Alright, and then I need an SDL underscore event variable to handle the event. Actually, I only want to handle one event whenever I press the escape key on my keyboard. Okay, we need an IP address structure. IP, this will be the IP address for the server, so this is the IP address structure. If you've seen my SDLnet tutorial, probably you have seen that, and immediately fill this up, so we will not forget. So SDLnet resolve host. Okay, and the first parameter for this is the IP structure, the second is null, indicating that this is the server, we are not connecting to anyone, and the third is what kind of port do we waiting for the connection. This is 1234 for the sake of simplicity. Of course, as I said in the other tutorial, it can be anything, basically just stay away from the common port like 21 and 80 and use some port which no one really used. Okay, and then we need a vector of data for every single player, so std vector, and this will then the data type is just data, and just call it socket. What should I call it? Socket vector. Right, and then we need a temporary variable, char tmp. This we will use to store the incoming data and outgoing data. Okay, and the bool running, this is the same as usually, so it's a boolean variable while the while loop is actually running, so whenever we press the escape key it will be false. Okay, and actually there is some new material in this tutorial, and this is the socket set, the SDLnet underscore socket set. I haven't mentioned this socket set type in the original SDLnet tutorial, but I believe I can explain it right here. So basically the problem with storing the sockets for each individual player like we do in here in the vector is that the SDLnet underscore TCP underscore receive call is something called blocking call, and that's pretty much mean if no incoming data comes from the socket which we passed into this SDLnet TCP receive function, then pretty much the entire program will stuck in this call. So it's not exiting, it's just waiting there, waiting some data to income. But if the data never income, for example, because the player disconnected, then the entire server will freeze. So it's basically not working anymore, and that's a problem because we would have to restart the entire server in order to again working. To solve that, I use whatever the manual for the SDLnet suggests is to use a socket set. And the socket set is basically just a vector of sockets. Basically, that's the easiest way to explain that. There is the add socket and the del socket, which is delete socket from the socket set. And then we can use two kind of function, one with the TCP check sockets, and the other is TCP socket ready. These two function is actually determining if there is incoming data in the buffer, and we only call this receive function whenever there are incoming data. If there are no incoming data, then we don't care about that socket. That's the basic idea. I will show that later on in the code, maybe it will be more clear. So I just call it sockets, right? Okay, and then pretty much that was all the variable which we needed for this server. One thing is left is to create a window. Although this server will not have graphical output, the window is still needed because whenever I press the escape key to quit from the server, if I do it in the terminal without with graphical mode, so without window, then it's not reacting. So that's why I need it. So we will actually exit out from the while loop. So SDL set video mode 604, 180, 32 SDL SV surface. So just the default definition of a window. Right, and we can make the while loop right here. So while we are running, So while the server is running, we do the following things. But actually, I think I forget one thing. Of course, I created the IP address, but I haven't created the actual socket for the server. So I have to create one more variable, SDLnet underscore TCP. Actually, first of all, the type is TCP socket, and just call it server, and this is equal to SDLnet underscore TCP underscore open, and it's just waiting for the IP structure right here, which we have filled up with this call. So now we have a socket for the server. Right, so we can use it to determine if there are incoming connections. Okay, in the while loop, first of all, I go through all of the events and check if someone tried to quit. So while SDL underscore poll events underscore event, and if event.type is equal to SDL quit, or event.type equal to SDL key down, and event.key.keysim.sim equal to SDLK escape, then just make the running equal to false. And that's right. So if I just check if we press the escape key right here in the upper right corner, or we press the escape key, then we just exit from the server, so we can free the resources right here. And actually, before I forget, we should free the server as well. So this one. So SDLnet underscore TCP close and server. Let's just free the resources, and so we can connect again to 1234 port without a problem. Okay, the next thing is actually try out if someone tried to connect to us. So TCP socket, and I just call it TMP socket, and this is equal to SDLnet, oops, caps lock, SDLnet underscore TCP underscore accept. Right. So if someone tried to connect to us, so this waiting for the server. So if someone try to connect to the server, we will do the following. So basically add it to the vector as I said. So if this is not null basically, so if TMP socket, then first of all we have to check if there are enough free spaces. So if we didn't if we are over the max player, which in my case will be 30, then we do not let the player connect to the server since we are over the maximum. And by the way, I just realized that I forget something. I make a variable for the socket set, but I didn't initialize it. For initialization of socket set, there is a call which is called SDLnet underscore alloc socket set, which is allocating a socket set, basically reserving a place for all of the sockets for this number of sockets. So basically this say is that the maximum number of player is 30 for this server, and actually we have to free this socket set as well with the call SDLnet underscore free socket set, and just waiting for the socket set name sockets. Right, so that's right. So we have a socket set. You will see how to add a socket to this socket set. Basically, you can just imagine it as a vector for the time being. So if someone tries to connect us, check if we have the free places. So if the player number is less than 30, and as we will send some error message back to the user. Okay, so if the player number is less than 30, then we just add the socket to the socket set, SDLnet underscore TCP underscore add socket, and socket TMP socket. So what this call does is basically add the TMP socket to the end of this socket set, which we have allocated right here. It's like the pushback function if you imagine it as a vector. Okay, and I will add it to the end of the vector which we have created here, the socket vector as well. So socket vector dot pushback, and I just create a new data, and let me see what does it waiting for. It's waiting for the socket, which is the TMP socket. It's waiting for the timeout, if I remember correctly, yes, and the ID. So the timeout is basically the current time, so SDL get tigs, and the last parameter is the ID. The ID will be represented by the current ID variable right here. Okay, and then I increase the player number because one player is connected. And then I have to create a message which will send back to the user. If you remember from this dir right here, oops, not this frame, but actually a little bit lower frame. That's right. We send back a 0 and a space and an ID, which is the current ID of the player. So I will use the sprintf function, sprintf function, which first parameter of this sprintf function, which basically converts something to a string, is the string, which is I created right here, called tmp. So tmp. The next parameter is the basic pattern, which it should be, which is a 0, and the %d, where the %d will be the id. The %d stands for that this is a decimal, basically an integer. Okay, and I just pass the current id here. So it will first create something like 0, 0, then it will create something like 0, 1, 0, 2, so on. Okay, and then we will basically just increase the current ID, so the next player will get a different ID, the cur ID ++. And actually, for testing purposes, let me write out that someone is connected. So std cout, so later on if something not working, we will know where to search for the problem. A new connection, and just write out the ID, cur ID, and just write out a new line character right there. Okay, that was simple. And in the case of the else statement, if there are not enough free space left, we will just send back a different kind of data. So sprintf, and again first the tmp array, then I will send what number should we use. Use the number 3, indicating that the server is full. And actually I just forget something. There has to be a new line character right here. Later on I will tell you why, but basically the problem is that that our message will not necessarily go through the network in one piece. So basically sometimes the message could be fragmented. So first of all, just send 0 through the network, and then the %d and the \n through the network. And of course that's a problem, because we have to know where the message ends. And for that I will use a special character at the end of each string, which is in this case the new line character. So if we read a new line character, we know that that was one single string, so we can concatenate them together. So I will just send a 3 and a new line character right here, and it doesn't wait any parameter, because I don't use any % characters. So what it is, and after that I will just send this tmp array via the network. To do that I will use the sdlnet _tcp_send, and the first parameter of this sdlnet tcp is the socket, the tmp socket. This is the socket which the player used to connect to us. Then what we want to send, which is the tmp, and then the length of the tmp, which is strlen tmp +1 and tmp, because that's the length of the message. Okay, and did I include the... No, I didn't include the C string header file, because we need that. So C string, because we need that to handle the message, the strlen, so you call this. Okay, and actually that's pretty much it. So after this call, we basically just check every single incoming connection from any player in the vector. So now we will go through each of the clients. So this client, this client, this client, and basically check if they have incoming data. Okay, so I will, what is it? Oh, this is the outer while loop, so I will do it right here. So check for incoming data. Okay, so we will check incoming data right here, and this will be one new function call which I haven't covered in the past, but I just explain it right here. So while sdlnet _check socket, and it's waiting for the socket, which is our sockets, and then timeout, which basically just wait how much time should it wait for connection. I will just say 0, so it will return immediately. And while this is greater than 0, we will do the following. So this sdlnet check socket will go through all of the sockets in our socket set and check how many of these sockets have incoming data, and return with that number. So if this number is 2, that means that 2 player is currently sending us some data. So this while loop will go basically until we process all of the incoming data. Okay, and then in a for loop inside, I will go through all of the sockets in our socket set. So int I = 0, less than, actually I will not go through with the socket set, but I will use the vector which we have created right here. So this socket vector right here. Okay, so I less than socket vector.size I++, and I will use another new function which is sdlnet socket ready. This socket ready function is basically tell us if this socket has incoming data. So if sdlnet _socket ready, and is waiting for the socket, which is our case is the socket vector I dot socket, because we call it socket in the data, and so we get the ith element and we get the current socket. Okay, and if this socket is ready, by the way, we wouldn't need this SDLNet check socket and the socket set, but the problem is that this SDLNet socket ready function only working if previously you have called the SDLNet check socket. So that's how it works. And that's why we need this entire socket set, else I will just completely ignore it and use a vector. Okay, so if this has incoming data, then basically we have to receive it and check for the first number which identify the communication. So we can check if the first number is 0, although that can be 0 actually because the player already connected. But if the first is 1, then we just forward this message to everyone on the server. If it is 2, like that, or 3 or whatever, then again just forward to the player, which so just do with the message what it should be done with the message. That's what we do here. So first of all, I will set this timeout function to the current time. So we know that there were an incoming connection just a few moments ago. So socket vector I dot timeout, right, that, so dot timeout with the e, timeout, equal to SDL get takes. So we just set the timeout to the current time, so we will know that there were an incoming connection. Later on I will go through all of the sockets, and if this timeout is greater than 5000, actually the timeout minus the current time is greater than 5000, so the last message received was more than 5 seconds ago, then we just automatically disconnect the player. Okay, then I will use the SDLNet underscore TCP underscore receive function to receive a message from the player, and I will receive it to the TMP vector. So socket vector I dot socket, so I will get it from the socket and to the TMP, which is our char array, and the maximum length is 1400. Right, I received a message. Now I have to check the first number. I could use something like scanf right here, but actually I prefer to go through manually with a while loop. So I create a variable called num, and this will be equal to the TMP 0 minus the number 0. So what this does is basically get the first character of the message and subtract the character code of the 0 from that message, so we get the number. So if it is a 0 character, then we get 0. If it is a 1 character, then we get 1, number 1 into the number. Okay, and I will use another variable. This is a loop variable j, and it starts from 1. Okay, and while we go through each element, so while the TMP j is greater or equal than 0, and TMP j is less or equal than 9, so while we are finding number characters in the string, until that I will multiply the number by 10, so number multiplied equal by 10, and then num plus equal to the data j minus 0. Right, and I just set j plus plus. Okay, so what this does is basically if they have a number 1, 2, 3, this is a character literal, then here first of all I set the number equals to the first character minus the 0. In that case the number will be 1, and then while we are finding number characters I will just multiply 10, so the number will be first 10, and add the current character minus 0. In that case we will add 2 to it, so it will be 12. Then again I multiply by 10 because the 3 is a number character as well, so then I get 120, and then add the 3 to it, so num equals to 1, 2, 3, so 123. This is basically how you can convert a number into a string to a number. This is a basic way, pretty simple I believe so. Okay, so now we have the number, so we have to check all of the cases. So if the number is equal to 1, so that means that a message which is sent every frame by each player, we just forward this message to everyone except the player who sent it. So I use a for loop for int j and not jk, because j and I already used. So if the k is start from 0, k less than socket vector dot size k plus plus, and if this k is equal to I, then just continue. So here I just say if the if the current socket is the same as the socket who sent the message, then we just don't send it back, because why would we send back the message which we have just received from that player? So in that case, continue as just send a message. So SDL net underscore TCP underscore send, and send the same message to every single one of the players. So socket vector I dot socket, actually not IK dot socket, and send a TMP and strlen TMP +1. Again, the +1 is for the null byte character. Okay, so I just received. Okay, I spot a mistype right here. This should be number. Right, so pretty much that's it, and this is just does what I showed you. So if a package with the number 1 incoming to the server, we just go through every single client. If this client is the same who sent, we don't send to him, because why would we send back the message which was just received from him, and send everyone else. Basically that's what it does. The next thing is if the number is 2, so here I will make an else if this number is equal to 2, then that's pretty much mean disconnect, although I think I use 3 in this dia, I'm not sure about that. But anyway, the number doesn't really matter. Yeah, I use 3 in here and I use 2 in here. Doesn't really matter actually the number. But in here I will do pretty much the same. I will just send the disconnect message to everyone right there, and this disconnect message actually contain the number 2 and an ID of this player. Okay, and here I just oops, the for loop, right, so I should copy the for loop as well. Okay, right here. Okay, I just go through everyone, send the message to them, the same message, and actually here I will delete the socket from the socket set. So sdlnet underscore tcp underscore del socket, which is just delete the socket from the vector. This is pretty much like erase from a vector, just this delete the socket from the socket set. Okay, and first the socket set, so socket, and the second is the socket which we want to delete. This is the socket vector I dot socket. Okay, that was it. Then I close the connection too, so sdlnet underscore tcp underscore close, and again socket vector I dot socket. This is the connection which I will close. Then I will delete this socket from the vector as well, so socket vector dot erase, to erase something from a vector, and this waiting for the pointer which should it erase. So this is the socket vector dot begin, which is the front of the vector basically, plus I to get the ith element. I delete this, and the last thing I do here is the player num minus minus to decrease the, so yeah, to decrease it. Okay, that was pretty much it. Then again we have another kind of message. This is the number field, so else if this number is free, that's pretty much mean that one player shot another one. So in that case I create a new variable tmp, because we will need it to read who this player shot. So scanf, and this message and the tmp, this is the array of characters, and then the kind of message which is free, and %d. The %d in this case will represent who this player shot. So I just get that %d and to the TMP, actually the address of the TMP. Right, so we will go through all of the vector, and if the socket vector is equal to this TMP, so the ID is equal to this TMP, then we send the message only to the player who was shot, not everyone, because it will be pretty waste of bandwidth to send everyone this message. This pretty much just for that player who was shot and the player who shoot. These two players should communicate. So I will go through all of the vectors. So int k equals to 0, k less than socket vector dot size k plus plus, and if the socket vector k is equal to this TMP, socket vector k dot id, so the id is equal to the TMP, then we just send the message. So sdlnet underscore tcp underscore send, we send the message to this socket. So I mistyped it right here as well. So socket set k dot socket, and the message is in the TMP, and the last parameter is the strlen TMP plus 1. That's pretty much it, and actually I break from the while loop because it might be more effective. So here I just break. That was it, and yeah, that is the whenever one player shoots another one. Of course, the decreasing the health is happened in the player who we send this message to, so it's not in the server. And pretty much that's it for now. These are all kind of messages. Of course, this can be extended by using more else if, or if you rather prefer to use switch and case, then of course you can use that as well. So you can use else if, and so on. The last thing to do is to actually check if this timeout has basically, so if the one player sent a message more than 5 seconds ago, then we just delete the player. So we do the same thing as right here, right this. Okay, so here after this while loop, right, we are in the perfect place. I will use a for loop, so for int k equals to 0, k less than socket vector dot size k plus plus, and if the socket vector k dot timeout, right, so if the socket the current time minus the timeout, so SDL get tigs minus the timeout is greater than 5000, then we just pretty much delete it from the vector. To delete it, I pretty much will copy this right here wherever we disconnected. Right, this actually not just this but this too. Okay, so this entire thing into here. Okay, perfect. And I will change one thing. I actually have to create a message because now we didn't get an incoming message which contained the ID and yeah, pretty much the ID and the message number. So I have to create another one. Just make it a little nicer format. Okay, so here in the if, I will create a message with sprintf, which just print a message to the TMP. The number is 2 and the %d, where the %d and actually a new line as always, because new line will always be the end of the incoming message. Alright, maybe here as well a new, okay, we don't need that. Okay, sorry to say that. So I will create a message like that, and the %d will be the socket vector k. Oops, I should use some other character right here, like J, and here as well, and here, and here. Okay, because I had a K right here in the outer for loop and in the inner for loop as well. So we have now different variables. Okay, so here I just socket vector J dot ID. So we just pretty much send everyone that player has been disconnected. Pretty much we can send it to the player who we disconnect as well, because who knows, maybe he's connected yet, and then we just let him know that we are disconnecting him from the server, so he should just reconnect back. Okay, so we delete the sockets, and I should use the socket J, and here as well socket J. Okay, I'll just make sure that I use the correct variables everywhere. Okay, here it should be K, up here. Okay, I think I used the correct variable everywhere. So now we just disconnect the player. So disconnect, that's the timeout. So we just disconnect the player if something happens, if the player doesn't send a package for 5000 milliseconds or 5 seconds. And I think we are pretty much ready with this whole server class. One thing I will add is add a little bit of delay right here, although I may not do that. Let's add a small delay, so SDL delay, and just add a 1 millisecond delay, so it will not run our processor 100% always. And then we close everything, and here actually we should go through all of the players. So for int I equals 0, I less than socket vector dot size I++, and delete every single player by using the SDL TCP close. And here I just socket vector I dot socket. Right, so I just disconnected all of the players. I just deleted the socket for them. And pretty much we are ready for the server, so we are ready for a try to compile. Okay, so I am in the correct folder, and I will try to compile the main.cpp. I use the lsdl and lsdl_net flags. And let's see what it gives us. Okay, doesn't have a timeout. Okay, another mistype at line 12. Go to line 12 and timeout with one I. Next is 33. SDL poll event without the S, so SDL poll event. like that, I believe so. Okay, 42 right here. Yeah, we need one more closing parenthesis to close the pushback function. Okay, line 66 right here. 66, this is actually TMP, not data, TMP. Yeah. Okay, line 93 is a bad conversation. 93 TMP. Okay, this should be, what do we want to do here? This should be we use the same variable name as our char, so TMP variable. I will read it to the TMP variable, and here I swap to the TMP variable. Yeah, that should be okay, because I use the TMP as our character literal and TMP right here as our temporary variable. Okay, line 97. I believe we have fixed that. Okay, I'll try it now, and it runs. Okay, I will not test this out right now because we have to work with the client a lot. So I will go to the client and create the network class, which will be the interface for connecting to the server. I have just opened up the files which we are going to work with. There are quite a few. This new file I created, this network.age and network.cpp file. This will be handling the networking stuff. This will be the interface. We need to do some modification in the game.cpp and game.h file as well. I created two new files, this enemy.age and enemy.cpp. This will just store the data for every enemy locally. So this is a simple structure, store the location, rotation, looking direction, current frame, so on. It's nearly not as complicated class as something like player or zombie, because there are no member function really. Besides the constructor, there are no member functions in this class. Okay, and I have opened up the player.age and player.cpp file as well. And let's actually start with that. We need to create a few member functions. For now, this will be just temporary, just for the sake of it, because else it will not work at all. So I have to add the unique identifier here in the player class as well. So int ID, and this will be the unique identifier at the beginning. This set this to -1, indicating that there is not set at the moment, so ID equals to -1. Okay, and actually I make a function to get this ID and set this ID as well. So void get actually set ID and setting to ID, and int get ID. This ID is the same as our server gives us, which we have created, you know, that current ID variable. This will be the same, just it is stored locally, so the player will know its own ID number. Right, okay, so let's make these two functions. This is pretty simple, and actually I need a new variable as well, which is called isReady. So bool isReady. This isReady variable will be set to true whenever the ID is set, as it is false. So basically you can only connect to a server if you have already ID, as you cannot send data to the server, because obviously then this ID variable is -1, and you know, that's not really an ID. This is basically just indicating that it isn't set. So let's make this void set ID and void get ID, and actually we need an isReady function as well. So this is a boolean bool is ready, which is return true if the ID is already set. Okay, so in the set ID I will change the isReady variable equals to true, because now we can connect to the server, and the ID equals to I. Okay, and the get ID will just simply return the ID, return ID, and actually we need this player : to indicating that this is part of the player class. Okay, and the last function is the bool player : isReady function. We just return the variable isReady. Okay, that was return. I meant return. Now that was pretty simple, and that's actually all the modification, if I'm correct, in the player class. Although I will leave the header file right here, because we have to use quite a lot of this getter function later on to, obviously we'll send these data through the network, so other players can know where are we on the map. Okay, let's actually do the game.cpp and game.age before I do the networking, because the networking is the real programming challenge right here in this tutorial. This is just pretty simple. I will make a variable boolean variable, bool is online variable, and this is online variable we will just set it manually, and if this is online variable is true, then we are trying to connect to the server. If this is online variable is false, we will just get the same old zombie shooter game with single player mode. So right here in the beginning I just set the is online variable to true for the moment, because obviously we'll try the online mode. Later on I will set this back to false so we can easily test out other properties of the game. Okay, and the next thing is actually we should get the ID of the server, and of course in a real game you probably want to get it via the graphical interface, so in the window with some tricks, but for now, just the sake of simplicity, I will read it from the command line. So I will make a array of characters. How many characters? IP 16 probably, with the points and with the dots and so on. Make it 20. I'm sure that 20 should be enough for an IP address. And if is online, then I just get this ID. So oops, IP. So std scene and just get it to the IP. That's it. I could use the get line as well. Actually, I should use the get line. So std scene get line, if I remember correctly, and the maximum number of characters. So the IP address is in the so in here. So if we type it to a terminal something like 100.0.1, then we are connecting to an own server, and it is in the IP. Although I haven't made this network class yet, let me make an instance of that right now. So here I will make a network net. Actually this is a pointer. Right. So this now I will call the member function before I actually create the member function. Usually I do the opposite way, but this is just so we can get rid of this game class and concentrate on the real programming challenge. Okay, so created a network, and if we are and if the isOnline variable is true, then I will initialize this net variable as well. So if we are online, so isOnline, then the net is equal to new network, and the constructor of the network will just wait the IP address, which is in the IP. We just read it right here, up there, right here. Okay, so we just initialize the network right here, and in the destructor we should delete it. So delete net. Okay, and in the update function we should send the data. So in the update function, you know what, that's for later, because I'm not sure yet what should I use as the send and receive. What data should it wait for? Okay, and what else is here? The enemy. Let's make this enemy structure right now. So as always, let's start with the inclusion guard. So if not defined enemy underscore age, then we define the enemy underscore age, and I see that I mistyped that. Okay, and if right here. Okay, and here will be our class, which actually should be a structure, because only public member variables will be in here. Okay, so this enemy class, it's not the same as the zombie class. It's just store a property of the enemy. These are basically what we send through the network. Okay, so every enemy has an ID structure, which is the unique identifier of that enemy. Every enemy has the frames, so std vector, unsigned integer, and just call it frames. These are obviously the animation frames. The enemies have collision, sphere, and just call it CS. We have a current frame, which is the current frame obviously, so I'm pretty much writing the same thing over and over again like in the player class. Okay, then the vector 3D position, and we have a rotation as well, so vector 3D rotation. We have a looking direction, although we will not use this right now, but might be useful later on, so look direction. And then the enemy has a health, which we could store in here, although pretty much the health, we shouldn't store the health too, should we? I'm not sure. Maybe we'll store locally the health as well. Okay, and it has a weapon, so weapon, and just call it weapon or core weapon or something, core weapon. Okay, and I believe we are finished. These are all the public member variable which we will need, and these are basically all the members which we are sending via the network, except this frames structure we will use that locally. But the current frame, what frame we already in the animation, we will send it via the network. Okay, and it has a few member functions like the enemy class. Maybe that's the only one, I'm not sure. std vector and unsigned integer, that just frames, and an ID. So whenever we create an enemy, we need to add the frames to the enemy and the current ID for the enemy. Okay, and of course we need a show. That's the last member function. So we have this two member function. The show is pretty much just go to the position, do the rotation, and show the enemy. Of course, later on then we will have something like armature animations or skeleton animation if you like. Then of course we can do much more complicated things in this show, like get the looking direction and change the bones, so it actually doing what it should do when the player looking down, so the head look down. But for now, always we do just looking forward. Okay, and yes, I said this is all. So let's implement quickly this two member function, which will be very simple. So include enemy.age, and the constructor will be just as simple as frames f and id I. Okay, and the show function, as I said, oops, we should put the enemy colon right here. And the show function, as I said, just go to the current location and draw the enemy. So first of all, GL push matrix, so we will not screw up our transformation matrix, and GL pop matrix. Okay, and just using the GL translate f to go to the locations of position.x, position.y, and position.z. And yes, I know whenever we are connecting, we not yet assign any values for all of this crap basically. Except the current frame, we should set the current frame equal to 0. Current frame equal to 0, although that's not really a problem because these are all public variables, and whenever we get a message from the player who this enemy class represents, we just fill up this entire structure. Okay, and do the rotation right here. So GL rotate f and what of course the rotation.x, and rotate it on the x-axis, and similarly do the y and the z. Okay, so like this. Y, Z. Okay, that was simple, and I will make just a scale f, so GL scale f. For now just leave it to 1, but later on if the enemy is too big then we get it smaller, and if the enemy too small we just make it bigger. And let's call the frame, so GL call list, and this list is actually the frames curve frame. That is basically how we always render something. So, and this was pretty much the entire enemy class, so I can exit from this. I will leave the header file here because later on we may need it. Okay, and let's go to the real programming challenge, network.age and network.cpp file. These are basically the interface for handling the networking, and as I said, we'll send character literals over the network. Probably we will only have one instance of this class. I've already do the inclusion stuff, so I included the SDL, the IO stream, the C string to handle the character literals, and a few things which we will send via the network. Okay, so we will obviously need a socket set, so SDN underscore socket set, which is, I just call it the server. Okay, the socket set will only contain actually one socket, the server, and the reason to use socket set is the same as in case of the server. So we don't want that if we don't get anything from the server, then the entire game just freeze and stop for time until we get something from the server. We want to even continue if we don't get for the current frame information from the server. We just don't move the other enemies, but we can move on the map. I hope it's clear. And we need a TCP socket, and just call it connection. This is basically the same as the only socket in the socket set. Okay, and actually I will put the temporary variable right here, so char tmp and 1400. It doesn't really matter, you can actually define it locally, and probably that would be more logical to define it locally since this is just a temporary variable, not really a part of this class, but since I will use it in every single function, I will just put it right here. Okay, and in the public I will make a constructor for that network, and as I said in the game.cpp file, it will waiting for the IP address, so const char IP. Okay, it has a destructor network, and this destructor will send the message to the server that we are disconnecting from the server, so the server will delete it. You get it, so delete from the vector, so it will no longer reserve a memory. Okay, we have a send function, and this send function waiting for a player, and this will basically send the most important data from this player class, like it get the health, it get the position, the camera position, camera looking direction, so on, collision sphere, and it all sends through the network in a specific format, of course. Then we have the send shot function, send shot. This, whenever you shot someone, this function is called, and this will send data about that the player was shot. So this waiting for the player pointer as well, so we will know that what weapon does the player use and what player, because obviously the ID is here in the player. And we get the ID. This is who do we shoot at, so who we shot basically. And the last thing is the strength of the weapon. Oh, we don't need that. Okay, so that was it. So this is the sendShot function. And lastly, the receive function, so void receive. Okay, and this receive function is waiting for a vector of enemy, so std vector and enemy, and this is actually a pointer and a reference, and I just call it enemies. So we will use a vector to store all of the enemies in the game. So all of the enemies who disconnects we remove from this vector, who connects we push it back to this vector. Right, okay, and we have a weapons, so a vector of weapons, so std vector weapon and weapons. Okay, we need a player, and actually surprisingly we need the frames which we will apply to the new player. Although this should be, I think so, I believe that this should be in a slightly different way, but for now I will just pass the frames into here. So std vector and this unsigned integer, and I just call it f like frames. Okay, and these are all of the member function for now. Of course you can add more member function if you want to extend the capabilities of this network class, but for now let's start to implement these. So right here in the network.cpp file, first of all I include the network.h. Oops, almost. Now that's it. Okay, and I will just format it quickly, network : oops. That's right. Okay, wait a moment, I almost finished. There we go. Okay, and in the constructor we first have to initialize the SDLnet. So in order to use the SDL function, so SDLnet init. Okay, and it doesn't wait any parameter. We need an IP address structure, so IP address, and I just call it, actually we should call it to this variable right here, IP char or something, so it will not be the same name, so IP address IP. And actually first of all let's try to connect to the server which this IP char represents. In order to connect we will have to use the SDLnet first of all, not connect, but first of all fill up the IP address structure, so with SDLnet resolve host, so SDLnet _ resolve host, and the first is the IP address pointer to the IP address, then the IP char, which is the character literal for the IP address, like I don't know, 127.0.0.1 for example, and the port, which is 1234 in this FPS game, because I just choose this port, it doesn't really matter what port you are using. And actually I will check for errors right here. If this return with -1, then I just write it out that there was an error. There was an error. For example, the IP address is wrong. STD line, I believe so. Okay, the next thing is to actually make the connection. So I already have a variable for the connection right here called connection, and connection equals to SDLnet _ TCP _ open to connect to a network, and this is just waiting for this IP address structure, I mean the address of the IP address structure. Now actually check if it was 0. So if this connection is equal to null, so equal to null, then there was a problem. So std cout, there were an error, and this is probably because of bad IP address, and I just make a new line right here, std end line. Okay, that's actually 2 new lines. Almost. Okay, so now we have examined that as well. So let's make a new socket set. So what is it called? Server. I call my socket set server SDLnet _ alloc socket set, and just we need actually just only one socket in this case. So it's really just not too useful to make this socket set always, but we have to make this socket set in order to check if the socket is active or not active. And the last thing is to actually add the socket set connection to this socket. So server dot actually not dot, it's not object oriented yet, so SDLnet _ add SDLnet _ TCP _ add the socket. I'm not used to use this function too much, that's why I'm a little stuck with the name. So server and the connection. So we add the connection socket to this socket set. that's pretty much our constructor. It was not that complicated, but it wasn't that simple as well as sometimes it is. Okay, the next thing is the destructor. In the destructor, first of all, send the server that we are going to disconnect. Let me check the error message for that. So here in the main.cpp in the server, we can see that the message for disconnecting is number 2, so we can just do the unconnection right here by just sending a simple message which says 2, and actually a new line, because I use this new line to separate the string. So sdlnet underscore tcp underscore send, and we send to the connection, which is basically our server, to the message 2 and \n. And how many characters is it? 1, 2, and 3, 4. Okay, that's right. We just send these to the network, and we are saying that we are disconnecting from the server. Let's close the connection, free the socket set, and we are finished with the destructor. So sdlnet underscore tcp underscore close the socket set as well. So sdlnet underscore free socket set, and call it and this is called server. And the last thing is to actually close the SDLnet, so SDLnet underscore quit. Okay, and this was the destructor. This already get quite long, but we will get it longer as well with time. Mostly this receive function is quite long. Okay, and in here, first of all, we have to check if the player is ready, because if the player is not ready, we shouldn't send anything. So player underscore is ready. This is the function we just made a moment ago. Which is basically the is ready will be true if the player is already assigned an original a unique ID identifier, as it is just false. So first of all, we have to get some data about the player, for example the looking direction, so vector 3D and vector, and this is just simple p, and I get the camera and I get the vector. This is basically the looking vector, which I said that we are not going to use. Okay, then the next thing is to actually print the data which we want into a string. We use the sprintf function for that, which print a formatted data into a string. So our string is called, what does it call? It's called tmp, and I just send the next thing to the server. First of all, a number 1 indicating that this is a message which we send every frame. The next thing is the current frame, and actually first of all the current ID. So this is a %. We should write it somewhere here. So like right here, 1, then the ID, then the current frame, because this will be important whenever we receive the data. We have to know the order what we receive basically. So the current frame. Then the next thing, so the current frame is %d. The next thing is the position, which is %f. So this is free floating point number. The rotation, so position, and then the rotation, looking direction. So again, free floating point number for the rotation as well as the looking direction. Okay, and we will send the health and the index of the current weapon which we are using, so index weapon. Okay, the health is just a %d, and the weapon is a %d as well. Okay, we just get these data from the player class. So the ID of the player is p get ID. This is the function which returns the ID. The current frame, we don't really have a function for get the current frame, do we? I don't think so, because we don't even have frames in the player class. That's a problem. So temporarily, let's make a function for that. So int get current frame, and let me implement that. Although I close that file, wait a bit, I will open up in a moment. So player.cpp, that's right. Okay, and here I will just make int player : get cur frame. Later on I will implement a really moving probably copy from the zombie class, but for now just return with 0. So this is just tmp, a temporary stuff, so it will work. Basically we can test it out. Okay, so p get cur frame. The next thing is the position x, y, z coordinate. We have a function for that. P get collision sphere dot center dot x, and similarly to the y and the z as well. So y and z. Okay, the next thing is the get the rotation. We don't have a function for that either, so we have to make that. Okay, this will return a vector 3D and get rotation. And we don't really store the rotation in the vector class, in the player class, but we store rotation in the camera class. So that's the way I will make this function. So vector 3D player colon get rotation. And for now, this is a temporary. This is kind of temporary as well. So return with a new vector 3D class, and this with the rotation on the x is 0. The y is the cam.get this one, and finally the z. So this is how we can get the rotation, basically. So the rotation only in the y-axis. We don't rotate in any other axis currently. Okay, so we use the p get rotation.x, and similarly I do with the y and the z. So yz. For the looking direction, I already make this vector right here, so just make it vector.x, vector.y, and vector.z. And the health is basically, we have a function for that in player get health, if I remember correctly, but I will check it. Get health. We have a set health, get health right here. So we already have a function for that. And the current weapon, we don't have a function for that. We have this get current weapon, but it doesn't return with the index in the weapon class. It's returned with the actual value. So again, I will make a temporary function for that as well. So get weapon index, for example, that will be the name. And for now, this is just temporary as well, and return with 0, because we already have one weapon. At the moment, later on when we will add, we will change this. Okay, so return 0, and again this is a temporary way this is temporarily as well. Okay, so we just send all of the data. So p get weapon index, we just send every data via the network. And actually, as I said, we use this new line character at the end of every single character literal we will send over the network, because this will indicate that we are really at the end of the string, not somewhere between them. Alright, and the next thing is to actually send the data, and I will use a little bit different method to send a data right now than I used. And actually I will change the method which gets the data and send the data right here in the main in the server as well, in the same way. The problem is that sometimes the network can send your package in your message in one package. It rarely happened, but it happened with me whenever I tested the program. Although I'm not sure if it cannot send in one piece or cannot receive in one piece. But something doesn't work, obviously, and so I used this simple method. So we need a variable called size, we need another variable called length, so length, and this will be the str len tmp plus 1. This is basically the length of this character literal right here. And I use a while loop while the size is less than the length. I will just sending this data, so size plus equal, and as I said, the SDLnet TCP send will return the size which actually was sent. So SDLnet underscore TCP underscore send, and I just send to the connection, so basically to the server, send the TMP, and actually not the TMP but the TMP plus the size. And the last thing is how many bytes do we want to send. We will length minus size. So what does it mean? This is basically doing that first of all the size is 0 and the length is the whole length. So it will try to send the entire thing, because tmp.size is just the beginning of the array and length minus size is just the length, because the size is 0 in both cases. So it will try to send the entire array. But if some reason, for example, it just send 10 characters, that means then the size will become 10. So we send 10 characters from the 20, for example, the size will become 10. And again, this size is not less than the length, because the length is 20, as I said, 20 characters that we want to send over the network, and the size is only 10, so this while loop will run again. And this time we will start from the 10th character. We don't want to send which we are already sent, and we don't want to send over, because we already sent 10 characters, we just want to send 10 more characters. So the 20 minus 10 is just 10, so we want to send 10 characters, and the TMP, which is the TMP is obviously our array, TMP plus size is a pointer to the 10th character. So basically that's how it's works. It's basically just this while loop will run until every single byte of data has been sent. Okay, and after that we are pretty much finished. We send this data through the network, and this was quite simple. The next thing is the send shot is a similar simple function. So let me just create this one. Okay, so first of all we have to check if the player is ready again. So is ready. Because if the player doesn't have a unique identifier, first of all, whenever I created this network, I didn't make this isReady function, and what happened is whenever I connected two player, somehow three player have been connected to the server, and I checked the ID numbers of this player, of this plus player, the third player, and actually it was some random numbers, and that happened because first of all this send data this send data sent the current ID of the player, but this player hasn't got a unique identifier yet. It has just some random data in it, and that caused that another player have connected. Later on we will receive in the receive function how we can connect. Okay, so again, first of all, let's sprintf, so let's write the data to the string, and let's check what the number for shot is. So I go to the main.cpp, and I think this is it, isn't it? Number 3. Yeah, number 3 means that we are shot another player. Maybe this number are not the same as in my GIMP presentation thing, but anyway. So number 3 means that we shot another player, and we will send, what do we send? First of all, we have to send the ID who do we shot at, so this is a %d, the ID who did we shot at, and actually the number of health is decreased. So number of health decreased, this is a %d, and the last thing is actually another %d, this is our current ID, and \n, because as I said we always do this new line stuff at the end. Okay, and so the first is the ID who did we shoot at. That's simple, that's just the ID right here which we have passed. How many health did the player decrease? We can get it as a parameter, but actually I can do p get current weapon. This will get the current weapon, get current weapon, and I get the strength of it, so get strength of that weapon. Although this doesn't work if it is a knife or a grenade or something, but for now it will be okay. The last thing is the player's ID, so p get ID. That was simple, and again I just used the exact same method to send it over via the network, this while loop kind of thing. And yeah, that was it. So the last and the most complicated, actually not complicated, but longest function is the receive function, which receives the data and do whatever it needs to done. So first of all we have to check the socket, so while SDLnet underscore check sockets are greater than 0, so again I just, it should wait the socket, and 0 meaning that no timeout. So while we are getting data from this server, we will run this while loop, and actually I make an end statement right here. So if the socket is ready as well, so SDLnet underscore socket socket ready, and this is the connection. So this is the two basic idea behind it. So first of all we check the socket, and if there are incoming data, then this socket set will be true. Okay, so while there are incoming data, let's try to receive it. Again, we just can simply use the SDLnet TCP receive, because we send it like this, so in a while loop, so if it can be several parts, and this is where this \n will be useful, because we can check if this \n has come, and if we had this new line character at the end, we know that we are finished with reading in. Okay, so I will use a variable called offset, and this starts from 0. This is basically the same as the size, and I will use actually a do while loop, so do and while. Okay, and in the do I will do the actual receive, so offset plus equal SDLnet underscore TCP underscore receive, and of course it's waiting for the connection, the TMP, which is our character array, plus the offset, and the maximum size is 1400. If for some reason this SDLnet TCP received have failed, then this offset will be less or equal than 0. So if the offset is less or equal than 0, then we just return from this function, because some reason this is failed, either the connection has either it disconnected or some error happened. Okay, and in the while loop I will just write that if the last character is actually a new line character, so if the tmp strlen tmp -1 is equal to a new line character, so while not equal actually. So while not equal to a new line character, we will continue to read in the data, because this new line character at the end of every string literal indicating that this will be the end of the data stream. And pretty much that's it how we read in, although I'm a little bit concerned right here, because although this actually worked, but I just realized that if I send so I will send a new 0-byte character, the null byte character over the network as well, then it should be -2, and actually I should use the null byte character to check, so if the null byte character is at the end. So I'm not sure a little bit, so we have to check this out later on. Okay, and let's check the message. What kind of message is it? So I will use the scanf scanf function, which scans from the TMP, and it starts with %d, where the first %d identify what kind of package is that. So 0 is the connection, 1 is the every frame data, so on, and the second indicates what the ID player send this. Or in case of, for example, the 0, so the connection, it identify the ID of your ID. So let me create a variable for that in type and ID. Okay, and first of all I read it to the type. We need the address right here, so type and int ID. Okay, and I just check if this type is equal to 0, that means the connection, if you remember the presentation. So right here in the main.cpp we send the message somewhere. We send the message 0 and an ID, and the current ID will be the ID which is sent. So in that case, just simple p set ID, and the ID will be the ID. This is just as simple as that. Okay, the next is a bit more complicated. So else if this type is equal to 1, that's pretty much mean that this is an every frame message. And in here I will just use a for loop to go through all of the enemies. So for int I equals 0, I less than enemies dot size I plus plus. So go through all of the enemies, and if the current enemy which we are which this I point at, so if enemies I get actually ID is equal to the ID, so if this is the enemy which send the message, then we just read in with the scanf function, and the scanf function will pretty much waiting the same pattern as we send in here in the send function. So this pattern right here. So this pattern should be right here as the second parameter, so TMP is the first, this pattern is the second, and now we have to determine where should we put all of these variables. So first of all, let me copy this comment right here I made. Okay, and the first parameter, this one, we don't read it because actually I write with 1, so the first thing we will read is the ID. Okay, and what should we do with the ID? Particularly nothing, because we already did something with the ID right here. So we can actually just ignore this parameter, so make a variable called tmp2. I don't use tmp because tmp is the name of the char array, so I just read it to tmp2, basically just ignoring it. The second is the current frame, and I will read it to enemies I and curve frame, I believe that was the name, and this scanf function actually with the address of this, so we have to make this very ugly format. The next thing is actually the current, yeah, that was it, the position. So a similar method can be applied right here. So enemies I, and in the enemies we used somewhere, I will find it, yes, right here we use the position right here. So this position, so get the position dot x, and similarly get the y and the z as well right here, so y and z. Okay, so fill up the position. The next thing is fill up the rotation. This is pretty similar, except that I will not use rotation as a variable name, but use not use position, but use rotation in here, here, and here. Okay, we read in the rotation. Next, the looking direction. I have a variable in the enemy.age as well, look direction. So again, this is pretty similar. I just use this and fill up rotation Z, and here look direction. Although, as I said, we will not use this one in this demonstration. Next is the health, which is the enemy's eye. Let me type this one. So enemy's eye and health. And what else? The current weapon is actually, we have to read this to a variable. I will use the tmp2 variable to read this. Pretty much that was it. We read in all of the data. The next thing to do is to actually assign the weapon to the enemies. So enemy, what? Enemies, right here, enemies. Okay, that's how I should type it. Okay, enemy's eye and current weapon. So current weapon equal to weapons, which are array of weapons. tmp2, which is the ID of the weapon. We assign it right here in the last parameter. Okay, and the last thing is actually to break out from this for loop. That was it. So pretty much we just read in. This was actually probably the most complicated case in all. The next thing is actually, if this for loop runs through but doesn't find an enemy with this identifier, that means that this is a new enemy. So we haven't encountered with this enemy yet, or it wasn't connected yet, it's just connected. In that case, we have to connect it. So if the I, and actually because of that, I have to make this I not part of this for loop but outside of this for loop right here. Okay, because in this way the I can be used in here outside of the for loop because of the scopes, you know. So if the I is greater or equal than enemies.size, that pretty much means that the for loop runs through and doesn't break anywhere. In that case, we have to add a new enemies. So a new enemy. So enemies.pushback, and I just add a new enemy right here. And this enemy will wait the frames, which is the F, and what else? Of course, the ID. The ID for this enemy is actually the ID right here, which we have read in. So just assign the ID. Every message starts with these two parameters, the type and the ID. Okay, the next kind of message is actually what else should we use? I think the number 2. So else if the type is equal to 2, what should we do then? I'm not sure about that, this message number, so I have to go to the main.cpp. Did I exit from that? Oh no. Main.cpp and check if the number is 2, then what message do I send whenever the player has yeah, the 2 is whenever some player has exited. So in that case, I will just remove this ID player, so go through the enemy structure. So int I equals 0, I less than enemies.size, go through all of the enemies, and if the current enemy, so if enemies ID is equal to the ID which we have read in, then just remove this enemy from the vector. So enemies.erase to remove something, and enemies.begin from the starting point, add I to it. That was simple. We just removed the enemy from the vector whenever the enemy has disconnected, obviously. Okay, and I guess the next kind of message is type free. So if this type is actually a free, what should we do then? I think that this is, yep, one player shoot another one. Because this is the receive function, we can assume that some other player shoot us. So in that case, I just decrease the health of the player. I need a few temporary variables, so let me create a few of these. So tmp1, tmp2, tmp3. Okay, and read in the data. So scanf, we read in from the tmp, and the pattern looks something like this: %d, %d, %d. The first %d, address of tmp1, which will ignore that because that's the ID which we have used, which we have read in earlier. The second is so the second is the number which was decreased, and the third is the player who shoot us. So now that we have read in, just decrease the health. So p set health to set the health of the player, p get health to get the health of the player, minus the tmp2, I guess, because let me go back up here and check. First we get the ID who we shoot at. Yes, that's our current ID. Yep. The second is the strength of the weapon, and the third is the ID of the weapon. So the second is the strength of the weapon. The third was actually, what was the third? So this is us, so this is the ID of us. The third is the ID who shot us. Yeah. Yep, this is it, and pretty much that was everything what was needed in the network class. So now we can call this kind of function in the game.cpp file. So I just find that file somewhere, game.cpp right here, and let's call this function. So first of all, the send function, we should call this send function every frame. So I will call this function in the update. So in the update right here, if we are online, so if is online, then just net send why, yeah, that was Control C, not Control V, and I wanted, okay, and just pass the player one right here. Okay, so we send the message, and the next thing is actually we have to create a vector of enemies. So std vector, and we create enemy, which is the structure we have created earlier, and I call it enemies right here, and actually we have to include that as well. So include enemy.age. Right. Okay, we have the vector of enemies, so now we can call the receive function as well. I will call it right here too. So if the is online, then we receive the data. So net, and just call this receive, and what parameter this receive waiting for. The first parameter is the vector of enemies we have created. So enemies, and actually, what's that name received? What was the name of this receive with not capitalized R? So the vector of enemies. The second parameter is the number, the weapons. We already have actually a structure for weapons right here, so we can use that. So weapons. The third parameter is I guess the player one, and the last parameter is the frames. That's a tricky one. Frames. I should do something about that because we read the frames locally, and actually I didn't. Yeah, we have to read the frames. Okay, that will be a bit, so this will be not the best solution, but actually I create a member variable to store the frames right here. So unsigned integer, I'm pretty sure there could be better way to do that, but this is the way I will do that. So enemy frame. Okay, and this enemy frame will be actually equal for now the zombie frame, so I don't want to create a new animation for that. So here I just loaded the zombie, and then the enemy frame is equal to the enemy. So what I did here is load the zombie frames, and actually the enemy will look like a zombie for now. Of course, later on we can make it better. So now I can just pass this enemy frame right here. Where was I? Yes, right here. Enemy frame. Whew. Now one last thing is remaining if we shot an enemy. So in here we have to go through somewhere when we do the actual collision hitting stuff. Yep, right here. Oh, that will be a long if call. So I will go through all of the bullets. Wait a bit. Yeah, I get it. So here in the outer if is true if the player actually shot. So we only have to do is using another for loop similar to these zombies, except we go through the enemies. So for int I equals 0, I less than enemies dot size I plus plus, and go through all of the enemies, and if we hit one of the enemies, so if collision, and I call the race sphere function, and this is again will be a very long function similar to this. First of all, we have to get the center of the collision sphere, and we don't really have actually a center for this collision sphere, do we? So collision sphere, we don't really set the collision sphere, I think. So let me go back to enemy.cpp, and in the constructor let me just make the cs.r equal to what was the collision sphere for a usual player 5, I guess. So I just set the collision sphere radius, and let's go back to the game.cpp and get the center of the enemy. So enemies I, and just we don't have getter function in the enemy anymore because everything is public. So get the position x, position.x, and similarly I get the position y and z. So position y, and position z. Right. Okay, the next thing is that whatever, so the direction, which will be the same. So direction.x, y, z, similarly that we did in the case of zombies. If you don't remember, this direction is a vector which this fire method will fill up, and this is the current, it is the direction of the bullet. The next is the center of the oops. Oh no, everything is okay. So for a moment I think I swapped this parameter, but now the starting direction of the ray, which is again the same as in case of zombies. So X, Y, Z. So this is the center of the player, and the last parameter is actually the radius, which is enemies i.cs.r. So if this was all true, that means we fired with the weapon, I will just call the net, the function for the network, so net, and actually only if it is online. So if it is online, although in theory if it is not is online, it cannot get in here because the enemy's vector is empty. So if it is online, then I will use the sendShot function, which waits for the player and the ID. SendShot, waiting for the player, which is player 1, and the ID who we shot at, which is enemies i.id. Actually, I should use this operator because that's a pointer. Whew, that was long. But I believe we are finished with most of the stuff right here. So let's try to compile it, although I guess there will be several errors. So compile everything. And LSDL, LGL, LGLU, and LSDL net. We need a lot of flags right now. And let's see how many errors do we get. A lot. I believe I haven't included anything in the enemy class, did I? No, of course I didn't. So include the vector, include the vector 3D, which we have created in the first tutorial, vector 3D, include the GL header file, so include gl/gl.h, actually we don't need glu, and include the weapon, include the weapon.h. Anything else? I don't see it. Try it again. Okay, that's still a bunch of errors. So let's go to the network.cpp and let's actually go through the errors. Do we have any other choice? So enemy.cpp, there are no such thing as vector 3D because I mistyped it. Vector 3D.h, enemy.h. Vector 3D.h. Yep, I forget the extension. Collision sphere is not the name of the type. This is similarly in the enemy.cpp. Collision sphere. Of course, we have to include the collision sphere.h as well. So collision sphere.h. Okay, the next error is actually collision sphere was not declared. Position, I missed that collision in the enemy.cpp line 8. Enemy.cpp line 8 position. This one is that position. Okay, and game.h, I will just go through the errors. Network has no type. I forget to include the vector, didn't I? Go back to the game.h and include the vector right here. So include network.h. Perfect. Next thing on the list is actually to recompile, because already we finished up with quite a few problems, and not too much shorter actually. I hope that we reduce the error by much. Requester cs game.cpp 152 right here, and the problem is that the collision sphere, what is the problem? The CS, something with the CS. Enemies I, of course we have to use the arrow instead of the point because that's a pointer. 215. I forget to close something. So if I close this one, did I close this one? I close it. What about this? This is the while loop. This shouldn't be the while loop, should it? Yep. Okay, something I forget to close. 215. Yep, this is online. I forget to close this one. Curly brackets. Right. Game.h 44. And probably some other problem, so we don't care about that. By the way, here is this knife. I made a tutorial about that, but I'm not sure if I should upload that. It gets pretty boring. Okay, so I'm not sure. Let's try to recompile it, I guess. So because I hope that we removed some of the errors. I don't want so many errors. Oh, crap. Game.h line game.h multiple type in one declaration. Oh, I'm not sure about that. Multiple type in one declaration. Line 44. I'm not sure. Anyway, let's go with the other errors. Apparently network.cpp line 3, and apparently it says that I make a return type for that. Okay, that starts to get stranger and stranger. I can't figure out what the errors are. Network.cpp line 13 in constructor 13 before. Okay, one error is that I haven't put this SDL reinterpret class right here. The name of the socket set is actually server, not socket as I originally wanted, so let's change wherever I use socket and change it to server. I'm not sure if I use it anywhere else, probably not. Okay, and the next is 74. This is because I forget a semicolon after the integer declaration right here, and pretty much that covers it. So let's try to compile it again and see what kind of error do I get. Right, I forget a semicolon after the network class, so this should fix a few errors. And what do we left with? Actually, one error we left with is the TCP close in the line 100. What line? Number 19 in the network class 19. And this TCP close waiting for the connection, so what it should close. Okay, I believe so. It will compile now. So there were quite a few errors, and this network class is the semicolon. Actually, it was a surprising error. Okay, so let me create a few new terminals to test this out. And in one terminal, I will just go to my server folder, so fps_game1/server, and I run the server. Actually, yeah, I can run the server, I believe so. Okay, this is the server running. As you can see, there are no graphical outputs here. Okay, and in here, let's try to start one FPS game and write the IP address right here, which is my loopback IP address, which is 001. Okay, here we go. It just started. Let me shoot this zombie because this will screw our demonstration. Oh, one thing I forget to make is that we need to escape somehow from the screen, because now whenever I click to the screen, it will use a mouse in, so I can't escape from it. I will just simply assign a button to escape, so I will go to game.cpp file, and whenever I do with this button stuff, I just assign a key, so key case SDLK backspace, for example. Then I just set the mouse into false, so the same way as I set the mouse into true. This is it. So the same way as I set the mouse into true, except I will set the mouse into false and enable showing the cursor, so I can change between different windows. It will be easier to demonstrate in this way. Okay, so let me compile and start the game again. Okay, the game is starting right now. I just write into my IP address 127.0.0.1. Here is one instance of the game, and shoot the zombie so it will not screw up our demonstration. Okay, and I press the backspace and our cursor is back. Okay, in my next terminal, let me go to the same directory, so fps_game, and let me try to run the same game and type the same address as 001. Start it, and here is our second instance, and let's see if the player is here. So shoot this one, and no player. Where is the other player? Okay, let me go back to the other screen and check if we can see from this player. Nope, we can't see it, so something is bad. Okay, and as you can see in the server, we can see the connection, so this actually worked, this part. And let me check why doesn't this network class push a new enemy. So did I call the show function? No, I didn't call the show function. I think this is what I forget it. So here I should call the show function if wait a bit. Okay, everything was okay. So it's online, then actually go through all of the enemies. So for int I equals 0, I less than enemies dot size I plus plus, go through all of the enemies and show the enemies. So enemies I show. And I realize that I forget to delete the enemies as well, so I go to the destructor and delete all of the enemies here. So go through all of the enemies and delete the enemy's eye. Okay, and let's try it again. So compile the program again and run it. Okay, there we go. I just connected with another player, and actually here is the other player. As although I can see both of my screen right now, you can only see one because I cannot push in here. But actually, I am controlling right now the other screen, and as you can see, here is one zombie. And if I go to my other screen, wait a bit. Here is my other screen. Here is the other zombie, so maybe you can see both in this way. So as I move in one screen, you can see the other right there. And if I go to the other screen, so backspace, and I go to this one and move the somewhere in this screen, go backspace and go back, and as you can see, I am beside me. So that's working. Let's try to add the third player right here. So I will find an empty terminal and go to my project folder, desktop, and fps underscore I set game, and let's try to run a third instance of this game. Okay, and I type in my loopback address again. Okay, here I have somewhere, because I have so many terminals already. Okay, the connection wasn't successful. It's the first terminal, right? I will try it again, and okay, the first terminal started. Maybe I have this mistyped IP address. Not sure, I can't look back that much. Okay, so here is the third instance of the FPS game. Let's just shoot the zombie to not screw the demonstration, and there are two friends, which are to me. Okay, and as you can see, here is one, and there is the other one. And oops, that's bad button, that was a nice thing. Okay, and here I am, and as you can see, I see the other two. And the third, which is this, I can see there, yep, it seems that it does actually working. Let me go. Okay, so here I am. I can shoot myself, but we will not die because I haven't added the die thing like right now. But if the health is less than 0, then obviously we are dead and playing the death animation. Okay, and for now I will just leave it like that. This program, I will not implement this current frame because already this tutorial was ridiculously long, probably the longest or the second longest tutorial already. And I think that the result is quite good, because now I can connect from different computer to the same server and just playing together with other players. That's a cool thing. The current frame is not that complicated to add. Probably we can add quite easily, and I will do that in a later tutorial. So that should conclude this one. So thank you for watching and have a great day.